Alrighty. Getting set up for day 22. I'm a little bit late. That's what happens on Tuesdays and Thursdays. Alright. As people trickle in, I am going to set up the day 22 files. Mod day 22. Oh, what's wrong with my keyboard? I didn't have the right mode set. Alright. Hey there, A Squared. How are you doing? Good morning, good evening to you. Good afternoon, no matter what time zone you're in. It's time to do Advent of Code Day 22. Let's make a new file, 22.txt. Let's make a new benchmark for 22. Let's go. Terminal 2221 cargo run 22.1. It's gonna be a lot of twos today. Let's clear off all this old code. Oh, we didn't have an input for day 21, did we? Day 20 had an input. Let's assume that there is an input. Okay, delete all the way down to part 1. Replace this with to do. Maybe 19 has a better template for me. Template response. Yeah, input string. That's what I want. Then just input. Yep. Yippers. Yep. String time. String time. Okay. Well, welcome to my stream. Now that our setup is complete, we're doing Advent of Code 2021. What is Advent of Code, you say? It's an Advent calendar of programming puzzles. Pick whatever language you want. It's 25 days of 2 puzzles each day. December 1st to 25th. This event has been going since 2015. Go to adventofcode.com. We're on day 22. I'm starting about an hour and 7 minutes late. An hour and 8 minutes late. So the programming puzzles have a theme. Usually it's a Christmas theme. It's pretty corny. So this year's theme is we dropped the keys to Santa's sleigh into the ocean. Whoops! To save Christmas, we got to get in our submarine, go down to the bottom of the ocean, and find those keys. So this is like, as we were unlocking each day, we're getting like further down into the ocean. We can see the caverns we went through. Every day there's a new story attached to the puzzle we have to solve. Let's see what we have. For day 21 yesterday, it was that we decided to play a game with the computer while we were waiting to descend to the bottom of the ocean. Now, I'm guessing we're almost to the bottom. Let's see what we have. Reactor Reboot. Operating at these extreme ocean depths has overloaded the submarine's reactor. It needs to be rebooted. The reactor core is made up of large three-dimensional grid made up entirely of cubes. 1 cube per integer, 3-dimensional coordinate. Each cube can either be on or off. At the start of the reboot process, they are all off. Could it be an older model of a reactor you've seen before? Day 17? Conway cubes. Conway cubes. Oh yeah, I remember that. That was fun. That was day 17 from last year. To reboot the reactor, you just need to set all the cubes to either on or off by following a list of reboot steps or puzzle input. Each step specifies a cuboid, a set of all cubes that have coordinates which fall within the ranges for X, Y, and Z, and whether to turn all the cubes in that cuboid on or off. For example, given these reboot steps, the first step turns on 3x3 by 3 cuboid consisting of these 27 cubes. Second turns on another one that overlaps As a result, only 19 turn on, the rest are already on. Third step turns off 3 by 3. The final step turns on a single cube. After that's 39 cubes are on. So I guess that's our initial. So let me start over. So I guess that's one of our unit tests. They've been doing this for most days, where they give us an example and they say, well, for that example, this is the answer you should get. And it's usually highlighted. So they highlighted this 39 here. That's probably the answer we're supposed to get, right? And I think they might have given us more examples here. Here's a larger example. Great, I love larger examples. So we'll just add another part 1, not there. Assert equal something for our part 1 inner that. 590,784. This is why we have computers solve this, so we don't try to do it ourselves. I screwed that up. Okay. The last 2 steps are fully outside the initialization procedure area. All other steps are fully within it after executing it. So that's interesting. So there's an extra rule there. The initialization procedure only uses cubes that have x, y, z positions of at least minus -50 and at most 50. For now, ignore cubes outside this region. Okay, so we should encode that constant. So const init region bound I size. Well, we can make it a range. I size equal -50. I'll make it a range inclusive. All right. So how many cubes are on, considering that region? Get my puzzle input. Put that into 22.txt. Okay, let's do the parsing first. So for every line we get an instruction. And if we split on a space, actually, you know, I can just do a sequence of 2 strip prefixes to see if it's on or off. That's probably easiest, right? And then have a function that turns this into a cuboid. So do we need a type for that? I guess, yeah, just for convenience, we'll have a struct for that cuboid. So it's just a bunch of range inclusives. YZ. From string for cuboid needs to be imported and implement missing members. Type error, we're not going to have one. Split on comma, right? Actually, no, I can just pull them off by prefixes. Actually, you know what I'd rather do is split on comma and then pull by prefix. So we can say let parts equal s dot split on a comma. Let x equal parts dot next dot unwrap dot split. Not split. It's something prefix. Strip prefix. X equal unwrap. And then same thing for Y and Z. Actually, we can also have another function which gives me the range out of that. So I guess it's a free function. So parse range, some s gives me a range inclusive I size. So that's just splitting on the dot dot, right? So let start end equal s dot split once on dot dot unwrap. and then it's range inclusive. I guess I have to do this, right? Or do I leave that off? I forget how this works. Yeah, I think we leave it off, right? And we just put in like right here, start, parse, unwrap. Oh wait, what am I doing? I should just do this. Dot dot equal. Simple. There, easy peasy. So this becomes, in front of all of these, a parse range of that. And then we just end up with a self, right? Or with an OK self. X, Y, Z. Parts needs to be mutable because we're going to call next on 3 times. All right. Need to look at the prefix to see if it's on or off. So we'll do it this way, I guess, right here. If, whoop. No, first got to split into lines. So, and for each one, we're going to apply something. So do I start with them all off, right? They're all off. And if we're limited to 50, 50, 50 for now, I'm not going to use a vector because for now means part 2 are not going to be limited. So I think I'll go with a hash set of coordinates instead. So hash, let, what are we calling it? Grid. Mutable is a hash set new. And then for line in input.lines, I'll just map it through string trim, unwrap, function call to do there, import that. Was unwrap the wrong thing to put here? Oh, I guess I have to map it through unwrap, right? No, there's no, what am I thinking? There's no unwrap. For each line, I want to say if let some cuboid equal line dot strip prefix on space. Else if let some cuboid equal line dot strip prefix off space. Else unreachable. All right, so if it's actually, can I combine these somehow? Because I'm just going to have the same kind of thing here. Let cuboid equal cuboid dot parse unwrap. It needs to be a type. I guess for now we'll put in a type hint here, cuboid. Actually, we know what I want to do is pull that completely out. And actually, you know what I can do? I can take this out too and put it here. And remove, just call this cuboid. Right? It looks kind of awkward. What it's doing is it first tries to strip, it matches against the on there at first. And if that doesn't match, it tries off. And if either one succeeds, it yields cuboid. Otherwise, it's a error. And that is then put into through parse and unwrap to store in cuboid here. Use Endure and join chat. Hey there, Endure. How are you doing? Good morning. Hope you had a lovely sleep and woke up fresh, relaxed, and awake and alert. The chief of all sinners, how are you doing? So if this looks kind of hard to understand, one thing we can do is introduce another scope here. So that might make it a little bit easier to read. So it's like whatever this scope yields, either cuboid from on, cuboid from off. Oh, there's one problem. I need to also know which one it was. So let's say on comma, so that we can say true and false, and then I need to map that. So map cuboid to cuboid dot, well, on cuboid dot parse unwrap, so that we get two things here. And it didn't like that. Oh shoot, I can't do map. Oh, I don't need to do right. So it's, I didn't need to do that. just do that. Let that equal to that. And I have to say bool comma for now. Not for long, though. We can remove that type hint later. Right, string. There we go. That we want to say is a cuboid. Actually, that means I can just put that there, right? Yeah, it could figure it out there. So then we can say if on, else. And can I remove this type hint now? Because it should know that it's a Boolean, right? Yeah, from true, false. Okay. So if it's on, we want to go through the cuboid and turn them all on. So let's actually make an iterator for cuboid. So for chord, well, for XYZ in cuboid. And we'll say grid dot insert XYZ. Actually, then I don't even need XYZ, just chords. And then here it's, instead of insert, it's remove, right? Looks more functional. Yeah. So I need to implement iterator for this cuboid. Implement, well, into iterator, right? For reference to cuboid, I think. Into iter. Oh, is this how you do it? Item. Right. So this is the type that we get. So cuboid iterator, and item will be. Do we need an item here? Don't know if I need it, but it's iSize. iSize. And this will be cuboid iterator. Why don't I just let it consume it, because that's easier. So then yeah, we can just say into iterator here. So that's self.x, well, x is self.x, y is self.y, z self.z. Actually, you know what I'm thinking? Why can't we just put the position into the cuboid and then have it just return itself? Right? So we can just say enum. Actually, I don't want an enum. I just want an xy. I need some more names here. hold on. Let's rename that to XR for X range. And then YR and then ZR. And then I'll have an X, which is just an I size, YZ. And then this will just return itself. And then we'll just implement iterator for our cuboid. What didn't like about this? Conflicting trait. Can you not, like, have it return itself? The cuboid itself is just a range from one coordinate to another in all three dimensions. So it's like a subset of a space. Why doesn't it like me to do this? Conflicting implementations of trait into iterator. Oh, is it saying if I implement iterator, I don't need to implement into iterator? That's convenient. Okay, so we'll start off with x.start. Y is xr. Well, this should be called xr. This should be called yr, and this should be called zr. Start zr start. We will dereference. Okay. Right, I don't actually need to spell out the coordinates there either. And yes, we only need to borrow the coords for remove. Okay. Next. What's wrong with this? Oh, probably because let's say I moved out. So let's just move this there. And there, there, and there. We'll just say let. And then X, Y, Z, let it format it for me. Okay, cool. So then, I guess, yeah, if you implement iterator for it, it implements automatically implements into iterator just to yield itself. So that way it's easy. I just need to put something in here. So it doesn't really matter which dimension we do first. So let's just say if self.x is less than self.xr.end, then I want to find out what the next value of y and z will be. Actually, let's just get the coordinates. So let coords equal self x, self y, self z. And then self.y plus equal 1 if self.y is greater than or equal to self yr end, then self.y equals self yr.start, self.z plus equal 1 if self z is greater than or equal to, did I do this in the wrong order? I kind of want to do x, then y, then z. So it should be that, right? With x first. And yeah. Then we don't need to do that step. I just need to have another, what is it? What's this error that's telling me about? I don't have enough brackets, one thing. And this should say else none. If we get down to here, it's some chords. We need to dereference the borrow in all these places. I tend to think the Rust should do that automatically, but I don't know why it does not. Anyway, this is correct. If we haven't exhausted the iterator, then get the current position, and advance the x for next time. If it's at the end, put it back to the start and increment y. If then y is past the end, set y to the start and increment z. That when the next time we come around, if it's past the end, it's none. I think that works. Okay. And then it's just at the end, it's return the number of ones that are on, right? Yeah, I'm going to end up using a lot of memory, aren't I? A megabyte? That's okay. Hopefully my input's not enormous. It shouldn't be, right? It's bounded to 50 by 50 by 50 for now. So yeah, it's grid.length.toString. So let's run the test. It didn't parse correctly. Also, we never used this init region bound. I think what I wanted to do was limit the here. Or really what would be more efficient to do is to limit it inside the parse. Here, I think. Parse range. Yeah, so something like init region bound start dot min, right? No, max of that to init region bound and min of that. I need to dereference a borrow on that? Ugly. Too many punctuation characters there. I need to do that before I call them. That's so ugly. Okay, well, it's ugly, but we buttoned it up. But what was it? It was like line 47. It still has a error. Let's see what it is. 47, yeah. What's on line 47? Here. Oh, right, because it's y. We expect that to be y equal and then z equal. Okay. Bug fixed. And Doran, you want to throw down that ban hammer, or do you want me to? I don't think Enduran's banned anyone in a while. Flex that ban hammer. Do it. Enduran. Enduran, you still there? Come on, man. Maybe there's a delay. I should give you a moment. Nope. Okay, I'll hit the button. Banned. Thou art banned. Alright. We got 14, not 39. Why would I get 14 on still? For this small example. I guess we could print out here. Print line cuboids on. You know, lately I've had a lot of bugs in my first tries. 8, 15, 14, 14. Okay, no, it should be 27, not 8. So what did I do wrong there? Why does it say 8 and not... Oh, did I have another copy paste thing with X, Y, and Z? Let's see, X, R, Y, R, Z, R, X, X, Y, Y, Z, Z. Okay, that looks right. And then when we iterate, we advance it to x. Oh shoot, this is wrong. It should be greater than, and less than or equal to, because it's inclusive. Inclusive, not exclusive range. There we go. Oh, we're off a little bit on this last one. So what, it passed the first test? Yeah, okay, so it 27 19 additional. Yeah. Then it turns off 8 of them. Yeah, and then turns on 1 of them. Okay, so then the larger example, it screwed up. Probably because of this, right? Oh, I know why. It probably turned on 0, 0, 0. Yeah, it probably turned on 1 at the very end there. Yeah. Actually, it turned on 101. Why would it turn on 101 there? Oh, 50, negative 50 to 50 at some point, right? So I have a bug somewhere? Oh, negative 50 to 0. That's okay. So I did that range limit thing completely wrong. Yeah. I should have thought that through. This is wrong. So I have to find the intersection of the two ranges, not this, whatever this is. So you know what? I'm not going to do that bound intersection here. I'm just going to put this back the way it was. Yeah, thank you, Chief of all sinners. It should be greater than or... Well, it's an inclusive range, so we want to include the end. It's when we go past the end, so greater than. But that's, yeah, that was where the bug was. Okay, so how do we use that range? This would have been the best place to do it, but the problem is I'm using range inclusive. So I could turn it just to a range, and that way we can have an empty range. I just have to be careful about off by 1 errors, or I can deal with it, I guess, here and here. Thing is, these are huge areas we want to skip. I think I am going to do it back here, and not have range inclusive, but have it be just range. Do I have to include range? Let's see. Yes. Okay, let's change all these to ranges. So then I have to do like 51 there. Right, and all the ends are just members now, which actually is a little bit more convenient, right? Because then I don't need these asterisks in front. So, good call. I just have to be careful here. It's when if it's less than. And here it has to be if it's greater than or equal to, and here greater than or equal to. Get rid of these. And that. Okay. Get rid of this, and then I have to add one. What's it telling me here? Cannot say it. Just type annotations needed. Why type annotation? Oh, sure. Because when we add one, there are lots of different implementations of add. All right, fair enough. Yeah, because now I can go back to parse range. Where was it? Yes, I just was there. So let me think about this. The intersection would be if start is less than infinite range bound end, right? And end is greater than or equal to init start. And then I still have to do a little bounds thing in here, right? Else we just do 0 to 0. Oh, map here? No, just do this. Start equals start parse unwrap. Yeet! Mr. Cool Milk Guy, how are you doing? Don't need parse... Whoops. As I was saying, I don't need parse unwrap there, and I don't need it there. It's gonna tell me, yeah, it needs some... It's not smart enough to figure out the type for that, because we're having to add one. Okay. This means if it intersects the init region bound. Right? Is it an and or is it an or here? This should be equal, right? Because it could intersect right at that end. No, I can't because the end is actually 51. Right, so there's a lot of potential for off by ones here. I think I want to put the mins back in here. So here's going to be a max, right? So this start, max start. And it's to this min of that. N dot min. And then I probably don't need this anymore, right? Yes, I do. I still need it. Let's see if I fixed it. Tricky. Intersecting ranges. Nope. It's still inserting 4 for some reason. Why would it do that? I guess I could print it out. Thank you for the follows. Where is it? Where is it? Here it is. Debug. Let's see this range. Hey, Quantum Apprentice, how are you doing? Okay, that's wrong. I think that's wrong. It's this one that's having trouble with, right? Oh, one of the ranges is valid, but the other two are not. I need to check that. Yeah, okay, where do we do that? In Parse Range? Well, no, hold on. We can let it parse. Okay, I got rid of my output. I'm too quick to close these windows before I'm done with them. Right, so the X was within range and the Y and Z were not. So what if I just put an extra test here? Empty bool. And it's empty if any of the ranges are empty. Hey, Andorn. I had to ban someone. I gave you a chance to ban them first, but I guess you were getting in the car or you were driving. But eyes on the road, Andorn. Stay safe speeds. Excuse me. We had one of those want to be famous, and of course I don't want to be famous. In fact, I want to be infamous. If they had said, "Do you want to be infamous?" I would have gone for it, but no. They just asked me if I want to be famous, so I had to ban them. You had a struct inside of a struct, maybe inside another struct, you're not sure, and you can't figure out how to get the compiler to dereference the address correctly. One thing to remember in C and in Rust is that structs are really just a way to smash values together. So it's like if you had these values just next to each other in memory. The struct is really just a way to package things together. So if you think about it that way, that it's just like a compound type, it doesn't add any kind of extra level of indirection on its own, then maybe that might help. Usually people get the addresses of structs because there might be so many things inside that it's just expensive to copy them around, but you could use structs in Rust or in C as value types. That's fine. It's just a tagging system. It's a packaging system, right? So it lets you with one name carry around a whole bunch of things. And also in Rust and in C++, you can attach functions to it. But in C, it's even simpler. It's really just a way to package variables together in memory and conveniently pass them around from one place to the next. So I should like figure out if something is empty here, right? Let's do this right here. Oh no, I can do it here. Let empty equal xr.isEmpty or yr.isEmpty or zr.isEmpty. And then we'll just put empty here. Just to shortcut this out. So we'll say if self-empty, return none. I think that should be enough. It's not the cleanest, but this should work. And we pass. I should probably get rid of all that debugging now that it passes, right? Debug. Okay, run the test again. Probably getting ready for work or de-icing the car. I also have cuboids. That's right, you live in a region of the world where you have to de-ice things. You should come live here, Endorn, in California, where we don't actually have winter. Not really. It's a little colder this time of year, but not that much colder. This is pretty slow. I'm worried about how long this is going to take. No, we have entered unreachable code. What's unreachable? Did I save it on in the correct file? I did. Oh, I didn't hit save. That's probably why. No, that's not it. Did I include the correct file? I did not. Include the correct file, Raimu. It parsed the input for day 20 instead of day 22. Okay, it wasn't that slow. On to part 2. Now that the initialization procedure is complete, you can reboot the reactor. Starting with all cubes off, run all the reboot steps on all cubes in the reactor. Consider the following reboot steps. After running the above reboot steps, that many cubes... Oh, okay. So, yeah, we're going to have a problem with memory. Just for fun, this many of those are also in the initialization procedure region. Yeah. I'm feeling like this is going to need to be an octree solution. Right? Or something like that. Where we don't track the individual cubes anymore. We track, like, cuboidish regions. Right? Yeah, I had a feeling that they'd do this. That's okay. That's okay. We can survive. We can thrive, even. Yeah, we can't do the brute force solution of remembering where every single cuboid is. We need to go, like, macro cuboids. Where's that huge number? Here it is. A very large number, and we don't have that many memory locations. So, Let's start with our initial solution, because the parsing is going to be the same. It's just that we can't use this hash set, and we can't do this insert. So what if we just tracked cuboids? How are we going to how are we going to collect these cuboids together? Sort them somehow? Do we even need to sort them? We really just need to have methods of, like, if something is intersect or within. Yeah. So the easy case is if they don't intersect at all, then we just add another cuboid to a list of cuboids, right? If they intersect, then we have two possibilities. Either they're adding, in which case we can represent that with just, we add the two cuboids and then we add an inverse. We add a anti-cuboid that would subtract on the intersection, right? Actually, why don't we just do that? Why don't we keep track of cuboids and anti-cuboids? So if there's an intersection, then we not only we add the second cuboid, but we add the intersection as an anti-cuboid. And then, but then we have to consider the intersection of cuboids with anti-cuboids. How does that work? If a cuboid intersects an anti-cuboid, they cancel each other out, right? I gotta think about this. No, wait. When something is on and you turn it on again, it just stays on. It doesn't change state. So I think we could ignore the anti-cuboids. I'm trying to visualize this, like, if we had to add two cuboids together, and we had to add an anti-cuboid to keep it from that region being counted twice, and then you add yet another one. Yeah, I don't need to consider anti-cuboids. We just add more anti-cuboids wherever cuboids intersect each other. And it's the largest intersection. Or actually, is it all intersections? Yeah, because we have the possibility of intersecting more than one. So do I consider every intersection? No, I can't. Because I don't know how many anti-cuboids to balance it out with. Is ... a range? Yes. Where do I have that range? Like here? That's an empty range. So where did I have a full range? Up here? So the type is range, and it's generic on the type of the bounds. So you could have U8, some kind of integer type, right? And it can be empty, like in the case of 0, 0, or not empty, and you can also have the start and the end of the range. Back to the problem. You know, really what I should do is just redo part 1 because it's smaller, and we can just make sure we didn't break it. I think I'd rather do that. So we'll just work on changing part 1 without breaking it. Hey, are you still driving, Endorn? We have someone else who needs the band hammer. He's probably still driving. Here we go. You can have the band hammer. That's 2. It should make a sound, shouldn't it? It should make a satisfying thud sound when I ban those bots. It doesn't though. It's like sort of anticlimactic. Okay, how do I do this? This is hard. Is it as simple as just every time we add a cuboid, we find all the intersections, and then we just add it on another set? Actually, if we have three, let's just say that we have cubes all on top of each other. You add one cube, you add the second cube, which is exactly the same volume. Instead of having like 2, you only want to have 1. So if you say you added 2, you should subtract 1. But what if you add a third that's on top? Then you have 3, and then you don't want to minus 2 more, because that would get you to 0. You want to only take 1 away. How do I do that? Okay, there's got to be a trick to think about this. Let me just put the rules up so people can read it as we're going. To read it as I'm thinking. You set all the cubes either on or off following these steps. Each one specifies a cuboid, the set of all cubes that have coordinates which fall within some range, and whether to turn all of them in that on or off, right? I'm wondering if I should just make this an octree. And then we would just have the octree of cuboids that are on. But I just can't visualize how I would do it. Should make a robot breaking sound? Yeah, that would be nice. Be a nice sound to make. See, someone who's worked on a problem like this of intersecting volumes probably got the answer really fast, and I'm just not that great at it. Would it be cheating if I looked up something online? Probably, right? I kind of figure I should try to figure this out on my own. So we have 3 by 3 by 3, and then we have a 3 by 3 by 3 that overlaps, and only 19 are turned on, that the rest were already on. How do we know that? We can do the intersection test. The intersection is always going to be itself a cuboid, right? So 27 minus 19 is 8. Yeah. Maybe I should write this down. So if we had like a cuboid, and then we have another intersection with it, we don't want that number to go up. If they're identical, we don't want it to go up. So I would have it, maybe we would add it, but then subtract it on the other side. But then what do I do if I have 2 of them? In this case, 1, just think of 1 as some space, right? So we have 1 cuboid that covers some space. And then I have that same space combined, intersecting, or union with the same space. I can model it as just adding the cuboid to an on list, but then adding that same cuboid on an off list, and it will all come out to be the same number, right? It'll be 1. But if I add a third, right? Then how do we model that? What do I put on? I would have to do 1 minus 1, right? To balance it out. But this 1 I added, to know what to subtract here, I would find it by, I see that this intersects this completely. But then it might intersect something else. So I would subtract 1 again, but how would I know that these are the same? I don't know. I can't wrap my brain around this problem. I think I'm thinking about the problem. I'm not thinking about the problem correctly. Back to the drawing board. How do we know? How can we track intersections and holes? Well, why can't I just count the number of intersections on the second list and then subtract them at the end? And maybe the way we would subtract them is we would find their intersections recursively? Okay, so then let me try that. So let me pursue this path. So part 1, rather than this stuff, and rather than having a grid, so we don't have a grid, we would basically have a list of cuboids. Yeah, I think what we want to do is have a list of cuboids and then reduce it by finding their intersections, and that's a subtraction set. Find the intersections within the subtraction set and subtract them and until we get no intersection. And then we just have a string of numbers that we're adding and subtracting. And then add that all up, and that's our answer. So I need a couple methods here. I need to have like volume of cuboid. So we have iterator, that's fine. We have from string, which is fine. Let's have this is one thing I haven't figured out in Rust yet. What the style point? Do people have custom methods first and then trait implementations, or do we have trait implementations first and then custom methods? I really don't know which one is better. Volume of a self to get an ice. We can go use size, right? Maybe better keep it I size for now. So that's if self empty. Actually, I don't care about that. It's just self.xr dot. Is there a length? Does that make sense? No. The exact length of an iterator. Oh, right, because ranges are sort of like iterators. So I guess it does make sense to make this a usize times self.wire.length times self.xr.zr.length. So that's the volume of the cuboid, right? And then we want to have another one that's like the intersection. Oops. Intersection. Other is another self. So then like the range, and really I should use this for inside of parse range anyway, right? Actually, this is the formula. This is exactly what I want, actually. I want to do that 3 times. Let xr equal doesn't really matter the order in which I do this, right? Self.xr.start less than other.xr.end and other.xr or self.xr.end greater than other.xr.start. If Then it's other.xr.start max self.xr.start to other.xr end min self.xr. And we don't need to consider the +1 there. I think I just do that 3 times. And here I just do all the y's. And here I do all the z's. Which makes me want to put this into its own function, actually. Kind of want to make that its own function. Should I do that now? I should probably do that now. Yeah, let's refactor this. So, in intersect range, left-hand side, reference a range I size, right-hand side, reference a range size, and that produces another range I size. And here I just put left-hand side dot in front, right-hand side. Left-hand side and right-hand side. Left-hand side and left-hand side. And then I can just, here I can just say intersect range start to end +1. Oh, I have to be careful about this. It has to be that, I think. Because here I need to say +1. And then init region bound. Right? Okay, we're borrowing. Start is less than end. And end is greater than start. Greater than or equal to, right? That actually stays. Did I have it wrong before then? I think I did. I think I was off by 1 before. Because if it's exclusive, then this is 1 past. So if end and start are actually on the same, they don't really intersect. Right? Hold on. What if that's 51 and that's 50? I think that does need to be that. So they're, yeah, one's going to be 51, another one's going to be 50. God, I can't think about it. This is hard to think about. I guess we can just test it as we go. Okay, the way I'm actually going to use it is we add the 1 initially, but to make it an exclusive range. And this already is an exclusive range. So this is the left-hand side. So let's say it's goes from something up to -50, right? So this would be, this would become -49, right? So -49 is greater than -50. We do want to include it. What if this went to up to -51? Then +1 is -50. It should not intersect it, right? Okay, I think that is correct. Okay, so we got our intersect range. Our parse range uses that, and I can also use it again up here. Yeah, intersect range of self dot xr, and the right hand side is other dot xr. Do that for y and z, so it cleans it up a bit. Okay. So again, just like I did for parse, I can just check if any of them are empty, then the whole thing is empty, right? I can just repeat this essentially. And I can remove the OK part. Okay, cool. So we can intersect cuboids. We can get their volume. So empty, the length will be 0. So any of these are empty will cause the volume to be 0, which is what I want. Okay, now we got the tools to work with. What I'm thinking of is having just a list of cuboids. So they don't need to be in any particular order. We'll just make it a vector. So this is just a vec new. And every time we parse one, we're just going to add it to the list. So grid dot push cuboid parse unwrap. Okay. Why is this unknown? Oh, that's right. It doesn't really know. Cuboid. Okay. Hold on. I forgot to consider on versus off. Oh, I was only considering the ons. How do I do the offs? I think what I gotta do is I have to do it inside of here. I can't just return this out. Yeah. Oh, this is gonna be tougher. I could have done it if it was just all ons. I didn't consider what do we do when we turn off. Off is just is gonna insert holes. Can I still model it in terms of cuboids and anti-cuboids? Anti-cuboid would be added if we have an off. And if we have an overlap, it's just that I add an off. Maybe I can? I mean, I guess I can give it a try, see if the numbers come out right. So I don't need this let here, really. We actually don't use this at all. Here goes here. That means I kind of need the concept of if it's on or off. And I don't know what to put for intersection yet. Maybe I won't put it in there. I'll keep it outside of it. So this would be tuples, cuboid and bool. And this would push the cuboid and a true. And so it would push a cuboid and a false. But then after doing this, we have to get rid of all the, we have to count for all the intersections. How am I going to do that? I guess before I push in here, I have to find all the intersections. I think then, yeah, we have to start with, we have to compute the intersections between that cuboid and everything else. And then that gives us a list of other cuboids. And then we have to find if there are any intersections within that set. And add that to another list. And then repeat until we find no more intersections. I don't even know if this is right. How would I even model this? These questions on advent code get tough when we get towards the end, don't they? I'm thinking for every cuboid we could have a list of holes in it. We can model it that way. That might be the way to go. That when two cuboids intersect, we could take the intersection and just add it as a whole to one of the two cuboids. And so they no longer intersect because one has a hole in it that matches the intersection. Maybe that's the way to go here. So then we would have holes is a vector of boxed cuboids. And you have to make it boxed, otherwise it's infinite size. See what happens? You get hilarity ensues if you do something like, oh, no, you can't. You can do that, but you can't do a cuboid there because it's now infinite size. We can do a vector because the vector's on the heap, right? Never touch your glasses with your fingers because you'll put fingerprints on them. So I can do that because it's on the heap. There's a level of indirection there. Okay, but it gets a little bit gross here because when we find the intersection with something else, and we have to say whether it's a hole or not. Actually, a hole would be not intersection, but difference, right? Yeah. How am I going to do this? So if you have a cuboid and you add another one, you would maybe take with the new one, you would find all the intersections, and those would be themselves cuboids, and then you would add them as holes. Which inverts all of the holes into... Okay, it's going to invert things. The more I think about this, the more I think I need to keep a group of ons and a group of offs. And when I form an intersection, then I was going to say we would have two ons and one off. And the off would be the intersection. The problem there is where, like, if I track it separately, then I lose the fact that one of the cuboids has a hole in it. I'd rather have the hole stay with one of the original cuboids like this. The problem is then if we intersect with something that has holes in it, what does that mean? Maybe intersect should just be for the ranges. Okay, let's do volume first. Volume should be that minus the sum of all the holes, right? And we'll make sure that the hole... Oh, wait a minute. The holes could intersect, though. What if the holes intersect? This is back to the problem again. Sure, we could have a cuboid with holes in it, but what if the holes intersect, we don't want to count their intersections twice. And they could intersect in lots of interesting ways. Lots and lots of interesting ways. This is stretching my brain. Do I want a tree here instead of just a single list? Effectively, there is a tree because each cuboid has its children there. This is a tree. What if I treat it like a tree and do a recursion here? Yeah, flipping the sign around. So this would be minus the. Well, how do I combine children together though? Maybe I don't want to have more than one child here. I'm about to give up on this for now. Just like what happened on day 19, because this problem is becoming too hard for me to get through, like the thinking part. Part of me wants to try to model this in octree as an octree, and we would just define the octrees in which a cuboid is in, and we turn them on. And then we find the inner, when we add another one, we do the same. We just add all the octrees in which it's on. And if we take away, then we would add a negative octree for that cuboid. Or at least where it intersects the ones that we're on. I don't know if this will work. So the way the octree works is you can divide space into 8 regions recursively. And then, like, if you have a super huge region that's all on, it doesn't take a lot of memory. You just need to record basically these ranges, and that's all you have. Even if these ranges are huge numbers. And then when you find the intersection, you're just finding the subdivision of the space, and this is where the problem is. How do I subdivide spaces? I don't know. I don't know how to do this. One thing that occurs to me is rather than tracking this empty here, we could just say if the volume is 0 for this iterator here. We could just say if volume is 0, then return none. You don't have to have this empty flag. Now think about it. Okay, if we just kept a vector of holes, then it's fine to subtract the sum of their volumes, but then we have to add back their intersections. And if those intersections have intersections, we would then have to, so let's see if I can do it this way. Minus the self dot holes dot iter dot map No, I don't know. We can't just we can't treat each hole individually. I mean, maybe I can. Hold on. Let's let mute volume equals. End up returning a volume, right? But in between, maybe we say find the holes volume. I don't know how to do this. What if we had another function that computed the intersections of a group of cuboids? If we had such a function like hole intersections, like this, if we had such a function, then what I could do is I could say volume minus equal the total of the holes minus the total of their intersections. But then it has to be, where do I put the recursive call here? Maybe volume, volume stays alone and I have some other function that is like volume of a group of cuboids, and there's where we compute their intersections. Okay, maybe we'll do it that way. So here it's just simple. And we have another function called intersection volume. And here we would have some slice of what do we call this? Cuboids? Eye size. Hey there, Resubaka. Good morning, good evening, good afternoon. I'm kind of struggling with this problem here. So here's where we can make it recursive, right? Because because each of these cuboids has holes in them, and we have to consider their intersections. Oh, but that's multiple slices. Gosh, how am I going to do this? This is hard. I don't know how to do this problem. This is too hard. Too hard. I'm not thinking about the problem correctly then. Should I back up and try a different approach? So obviously we can't do an approach that requires holding on to an object per cube, because that we would run out of memory. So that means I obviously need to hold on to regions of cubes just by describing them in some way. Problem is that they can overlap, and when they overlap, we don't want to count those overlapping regions twice. But then it gets really complicated because they could overlap and then you can turn off something within the overlap region. My watch is telling me it's time to go to bed. You could have something really complicated where you turn off a region where part of the region wasn't off to begin with, part of it was turned on by one cube, and part of it was in the intersection of two cubes. It might help to do this in 2D and then extend it to 3D, right? Maybe it would help if I do like paint. We can do some programmer art, right? So let's draw a rectangle, fill with a solid color. I said fill with a solid color. Do I have to pick a different brush? Color 2. There we go. Why is it blinking on and then turning off? I don't know how to use this tool. We're not going to use this tool. Paint.net. Where are you? Come to my rescue, Paint.net. Here it is. Okay, so this tool and right, so this actually has tools that'll help me. I want the shapes though. And we're back to this problem. Where's the button where it fills? Is it that I need to pick black for both of them? Nope. That's obviously not right. Here we go. Okay, so we have one region that we turn on, right? And then let's say we have another region in 2D. Here, the problem is that we have an intersection, right? That this region here, we don't want to count twice. Let's use different colors. What color do you use for the this one? Okay. So you have one region, and then you have another region that overlaps, and how do I draw this so that it... Oh, is that how we do it? I mean, I guess I could do it that way. So I could just fill with... There we go. So then this overlap region we don't want to count twice. So I'm thinking, well, maybe we keep track of the overlap regions as wholes. So it would be like I was originally doing it. This one. Only I need to put that back to the color it was on. There we go. So like this, we have one region here that's completely filled, and then we have one region here and we cut out its corner, right? So then what does it mean to add a region like this? We have a full region, right? And then we cut out this region here of this rectangle, and then we had to cut out this region of that other rectangle. But this region was in a hole, so we don't want to cut it out twice. How do I model this? Do I need to reduce this down to one dimension? Yeah, the instructions say like well, I'm doing it in 2D, but if we're modeling as 3D, like you can turn on, we turn on a rectangular region, then we turn on another rectangular region. They might overlap, so we don't want to count this inner region twice, right? So I have to either, if I have the volumes of those two rectangles, or the areas in this case, on one side, to balance it off, I would have to have the area of the intersection we subtract from at the end, right? But then they have other instructions to say, well, okay, now you can remove turn off sections. So what if you turned off that, right? It gets really complicated because now we've overlapped our subtraction area, and we've overlapped two regions that weren't overlapping before, and we turned off an area that wasn't on to begin with. So I don't know how to deal with that. Wait, hold on. Maybe we don't even need to store any of this information, because the problem just wants us to get a number, right? How many are on? Oh. I think I know how to do this. If we remember the original volumes, and every time we add a volume, we find all the intersections, and we just don't count that somehow. Then we would have, like, if I were to draw on this, we have A, and we have B, and then we have A, what's the thing for intersection? B. So we would just have A plus B minus A intersect B as our running total, right? And then, no, I wouldn't even need to do that, right? No, yeah. We would remember A, we would remember B, and we would remember this A plus B minus A intersect B. And then when we went to add, like a C, then what I would do here is I would compute C intersection with A, which I guess I can draw in a different color. How about green? Oops, wrong color. Green. So we have this region, and then we have this region. So if that is C, how do I think about this? We have A intersecting C, and we have B intersecting C, but those intersections themselves intersect with A intersection B. So it would be A plus B minus A intersection B plus C minus okay, if that's where if this is A intersect C and that's B intersect C. See, I don't want to subtract too many times. In fact, we don't want to I only want to subtract these three regions, right? No. A plus B plus C, we want to subtract, we do want to subtract this region. Which takes care of that inner region. So how do I find A intersect C? This problem is too difficult for me. Even in 2 dimensions. I don't know how to do this.
I can knock her up.
Because we have a lot of different regions here, right? We have A intersect B, we have A intersecting C, we have A intersecting, well, B intersecting C, and then we have A intersecting B intersecting C. Can you use unions too?
Wait, shield.
How would I? Maybe you're on the right track there. How would I keep track of a union? Thing is, the shape is very irregular. So, like, if I was keeping track of regions just by their dimensions multiplied by each other, so it's an area for a rectangle or a volume for a cuboid, how would I track a union? The union is really just the sum of their volumes minus the volume of their intersection. So it's easy for 2 areas, right? But when I add a third, that's where I don't know what to do. How do I track their union? That's essentially the problem I'm trying to solve here. How do I discount or not count these intersections more than once. Because the rule says once it's on, it stays on. It doesn't go on twice as much or something. And then when I solve this problem, then I have the problem of what do I do when like we start adding holes, which would be like flipping this around. What if I added a hole there? Now the hole it takes out some of it takes out that whole area from A, but if we're only looking at it from the perspective of C, it only takes out part of C, and it doesn't take out any of B. I mean, the simplistic approach would be find the one that that intersects the most, but even then we have a problem. What if it's this region? Now it's intersecting part of A and it's intersecting part of C, and the other part is not intersecting at all, and the part of the whole it's intersecting both A and C. I don't know how to deal with that. Is it time to get hints? I think it's time to get hints. I don't want to rage quit. I'd rather just like look on Reddit for ideas and just implement them. So we're just going to keep this a coding stream, not a solving an algorithm stream. Let's do that. So we can use this browser. I can go to Reddit. I can go to Advent of Code. Yes, Advent of Code. And there's probably a day 21. Day 22 solutions mega thread. Here we go. So I just want the idea of how to solve. I don't want the code. My implementation split cubes up when they overlap a lot slower and I'll get a cleaned up solution with inspiration from this thread. Initial implementation split cubes up when they overlapped. I think I see how we might do that. I wouldn't mind doing a brute force kind of solution. Sat down on paper and pencil trying to figure out the logic. Yeah, this is exactly what I was doing. Finally came to the answer, but didn't tell us what the answer was. I just want the answer without any code. Basic algorithm is every XYZ goes onto an edge list. Edge list. Then A for XYZ over... What's that mean? So we have a little box. And can't even understand what this person's saying. It's easier to do in Venn diagram though. Again, don't know Venn diagrams. See, I'm not a math guy. I'm not a diagram guy. 820 edges for coordinates and 420 boxes. Okay, yeah, I didn't understand that person at all. Inclusion exclusion principles. Computed pairwise intersections and three-way intersections from those, and at the same time adding such a... This sounds like what I was thinking of. The intersections actually appear much smaller than the theoretical maximum. This is good enough. Handing the off cuboids. Yeah, this is exactly what I was saying. The off and they're on. Somewhat tricky because it also depends on the order of the steps. After long trial and error, managed to get it working. What is the trial and error? I need to know. I don't want to look at code. No code. Use sweep line recursively. First sweep on the x values, calculating the area at each slice. To calculate the area of squares, sweep on the y's, calculating the length line at each slice. To get those...
CJ run the other way.
What does this mean? Use sweep line. First sweep on the z values, calculating the area at each slice? I don't understand that. I don't understand that. No cubes, splitting cubes or anything approach. Strategy just use sign volumes and track the intersections. Each cell would be in any number of the accumulators. Need to hydrate. So many solutions in Rust. Happy to see that. It is kind of cool. This one's in Python. Basically, when new on comes in, it first finds intersections with any existing positive or negative cubes and adds a new cube for the intersection with the opposite sign to cancel them out.
Every time you land, it's so good.
This way, the final tally of for all cells within the new cube has been zeroed.
Good job, CJ's good.
Final tally for all cells within the new cube has been zero. What does that mean? Then it adds a new cube with the positive sign. For the off lines, we do the same cancellation of everything intersecting in cube space, but then just leave them canceled. Oh, I've been talking too much without not getting enough water, and I'm out of water. Let me go get some water. I need to turn off the camera just a minute so I can get up and get some water.
CJ, I know he ulted. But he just can't die. His ultimate is he just can't die. It's actually really. She's
Okay, I'm back. I'm gonna turn the camera on. Here we go.
just watch out for.
Okay, what was very smart? I don't want to look at the code then. Use signed volumes and track the intersections. So we can do that. We wrote the code for that. Each cell could be any number of the accumulated cubes, so long as the final tally of the signs of the cubes containing is either 0 or 1. Final tally of the signs for the cubes containing is either 0 or 1. When a new on comes in, it first finds the intersections with any existing positive or negative cubes and adds a new cube for the intersection with the opposite sign to cancel them out. That's what I was thinking initially. This way, the final tally for all cells within the new cube has been zeroed. Then it adds a new cube with a positive sign. I see. Okay, I think I see that. So we would have a list of cuboids. When we're going to add a new one, we're going to find all the intersections. And those intersections that we add immediately with the opposite sign. Then at the end, if it's an on, we add it back. If it's an off, we do nothing. Right? Leave them canceled. I mean, we can try that. So I can still use my, so we're not going to track holes. We're going to still use the same intersection code. Intersect range, we're going to keep that. We don't need this intersection volume, though. And then it's not a grid anymore. Well, I guess we'll just rename it. It's... Oh, one more thing. I need to remember if it's signed. So I had this for a little bit, right? On, whether it's on or off. And when we're finding the intersection, I need to know... Actually, we know the signs, the on values of the two, so we know what to put in there, right? We put it in there to cancel. That's what we do. So this is going to be on is self dot on XOR, right? Yeah, XOR self other dot on. Yeah, exclusive OR. All right, and then where's the next error? In here somewhere? Yeah. When we're parsing them, they're all ons, right? No. We have to say which one they are. Well, we can just make it like... Yeah, I can just make it on. True. You know, actually, what I'd rather do.
I stunned him so he couldn't use it. Silence.
Because we already have redundant code here. Do it like this. Let mute cuboid equal that. And then cuboid dot on. Well, in this actually this is just push that without that. This is just cuboid. This is just like that. This, however, I need to turn it off. So cuboid dot on equals false, and then push it. Okay. Interesting that I had to say that and already knew the type and whatever. Okay, so then we can't just push though. We need to have a function that does this. So we would say incorporate. Borrow the grid mutably and then give it the cuboid. And it'll be we'll just use the cuboid's on or off value to say how we're doing that, right? So this is the function that will do the algorithm that our friend online, our anonymous friend, told us about. Cuboid. Actually, can't I just make that? No, it's on the grid. Sorry. Grid. Mutable slice of cuboids. Actually, no, it needs to be a vector because we're going to be pushing into it. And cuboid, right? So it's new. New cuboid. All right, so far so good. What are my other warnings though? We never use volume or we're about to do that actually. Actually, the volume we know, right? They said that we just tally up the signed volumes. Yeah, so that means I'm gonna update the volume here. It's let volume equal that. If on, it's just a volume. Else, it's negative volume. Right? And this needs to be an I size. As I size. Really should just put it out here. There you go. So then we're just going to do a fold. Grid.fold 0 volume comma whoops cuboid volume plus cuboid volume to string. We have to into iter here. There we go. I didn't like me using volume here because there's a tuple. Because this is the wrong kind of thing. This is not a hash set, it's a vector. And we're not doing this on-off junk. I'm not doing any of this stuff actually. It's unknown, so we have to say there's our vectors of cuboids. Okay. Oh, I'm wrong. I'm modifying the wrong code. Dang it. Again, Endurin. Now at work with coffee in hand. So, Endurin, while you were on the way to work, I kind of gave up trying to figure it out on my own. So what I did is I went to Reddit, and I'm not looking at the code. I'm just looking at the explanations of how people solved it. And basically, I was on the right track, but I didn't get the last nugget on my own, and I'm okay with that. I'd rather just implement. When someone gives me that last nugget, I'm going to seize that last nugget and realize it. So that's what I'm doing right now. You're unable to ban the second bot. You're driving indeed. Normal drive takes about 30 minutes. That's a pretty good drive, yeah. Not as bad as mine when I had to drive an hour. Last one is plus and pipe means intersection. Okay, but yeah. As long as you learn something from the puzzle, I guess it's worth it. So what I'm learning is that I was on the right track, but but I just couldn't wrap my brain around this concept of tracking intersections of intersections, basically intersections all the way down. I couldn't handle it. That's okay. I just realized I'm modifying the wrong part though. So I totally screwed that up. That's okay. I wanted to modify part 1 first. We'll just do part 2 in a minute. Okay, we're just modifying part 1 to work with this. So yeah, we're incorporating every grid as we read them, and incorporate's going to be the crux of the algorithm. Once we're done incorporating everything, we're just in order full, or it doesn't actually matter what order we do it in, right? We're just folding, because they don't intersect anymore technically, because they're all accounted for in terms of positives and negatives. We just add them up. And the volumes will make it negative if it's an off cuboid, positive if it's an on. And I had the right idea, it turns out, by intersection just inverts. So if it's off, it becomes an on. If it's an on, it becomes an off. But then the little thing that I didn't get is that we leave them off if we're adding an off. So incorporates what we got to implement, right? Any other warnings that aren't due to me not doing part 2 yet? We don't need hash set. Okay, incorporate. So they said find all the intersections with new cuboid with the cuboids in there and add those to the end with the opposite sign. So let's do that. Let intersections equal grid.iter.map cuboid. And this is already getting too long for me. Hit enter. To something that we're going to filter out, right? Actually, then we can just make it filter map. And push them. So that means that we want to compute them first. We want to collect them first and then add them onto the end. So I should just do a collect. And then we do grid.append mute intersections. Then if the new cuboid is on, we add it, grid.append new cuboid. Did you need me for something?
No, you're good.
Okay. I just heard my name saying I'm taking too long. And what's the error there? Mismatch types. Oh, it's not append, it's push. There we go. Okay. Need you to stream this. I am streaming it. Okay. It's let intersection. Well, let intersection is the name of the function, right? So actually no, it's a method. So I could say let intersection equal cuboid.intersection with new cuboid. And that will did I have that reverse the sign for me? Yeah, with XOR. So on with on becomes off. On with off becomes on. Is that right? Oh, wait, how long did did it go muted? I'm sorry. How long was that off? What did I hit that it went off? I hate it when that happens. I don't know when that happened. Okay, well, you know, you just missed me babbling. Don't worry about it. It's time to wake up again. A long time, a couple of minutes. Okay, well, it was just me trying to, with paint, get this algorithm through my head. Now I feel really foolish that I had the audio off. I must have hit some kind of hotkey by accident to turn the thing off. Thing is, I can't hear myself. I can only see myself. I could tell if the camera isn't working, but I can't tell. I have to look at the view meter to see if the audio is not working anymore. My apologies. What I was debating is whether when we do the intersection of cuboid regions, should this be self on, exclusive or with other on, or just inverted? And I think the answer is invert, because that's what they're saying here. Add one with a new cube of the intersection with the opposite sign, probably opposite of the original, right? Because we want the final tally for that one to be zeroed, which makes sense to me. I hope this is right. It's either that or it's exclusive or some combination. I guess we can just try. I can just try them all. Back to this part. We would find the intersection, and if the intersection is empty, then we want to filter this out, I think. So it would be none. Else, what am I doing? Just, this will format it for me. There. It's just some intersection then. Right? And what's wrong with this? This isn't mutable. So collect all the intersections with opposite sign and append them to the end of the grid, and then push the new one if it's an on. Is it that easy? Let's see if I got it. Where's my unit test? Huh? It got the right answer. So then part 2 is the same. I think, because the test does turn things on, but where were we using in region bound? Oh, I see. Yeah, so I have to be careful. This parse range is used in the parse. Okay, so I need to change this then. Let's not make this a parse. Let's make a custom method for this. Let's just call it parse to self, and then I'll include here the on, and also include here the limit as an optional range. Yeah, that's what I'll do. Limit option range there. And that way, this can just return self. On, we just pass in, and then parse range will have to include the limit. It really doesn't like this function. Why not? It's not a member of iterator. Oh, that's why. We're putting in the wrong block. It needs to go in this block. I still feel bad about keeping you guys silent. Or keeping me silent for you. I gotta get over that. We're moving on. Sorry about that. this should be if let some limit equal limit, then it's the intersection of that. Yeah, it's just limit. Else it's well, hold on, we had this, so let range equal that. Else it's the range. Okay, and then this parse, we can get rid of this one. Then when we parse in here, limit is that type. We're not doing from string anymore. Right, so then this becomes cuboid. Parse cuboid, comma, and then this one is a true. Borrow the, or it's sum, borrow the inner init region bound. This one's false, sum init region bound. And I don't need to unwrap that. It's off the side of the screen, you can't even see it, neither can I. It's too big. Okay. Make sure I didn't break part 1. Okay, and then that's good. So part 2 is just that without limits. So this just becomes a none. That's all I need to do. Run it. And it passes. Brilliant. Okay. And we get a very, very huge number. Just for kicks, let me try part 1 again. We should get the same number we did, right? Yep, same number. Okay. Finally, we are about to get a star. Yeah. Okay. It would have been great if I had figured out how to do it on my own, but yeah, it was too hard. I had to lean on Boojum. Boojum helped me figure it out. It was not easy, Endorn. I couldn't figure it out. All right. Wow. Okay. Clean this up and then go to bed. I didn't need this line. This doesn't need to be mutable. In fact, this can all go into here now. So here the only difference is... See, I don't like this redundancy. I don't like that. Go to bed at 9 a.m.? It's midnight for me. Okay, then I can basically take all of this and reduce it to solve. Input with a limit optional range eye size. Right? This limit is just limit. And this is just solve with input and this one. Part 2 is just solve with no limit. Right? Oh, I put it in the wrong place. It's late. Let's run our test again. Passing both tests still. I should run the benchmarking too when I'm done. Okay, can I... Is there a clever way I can use strip prefix I think there is. I think there is. It involves me separating this on versus off and then calling incorporate one time only. So hold on, let's move this out to here, and we'll just say let cuboid and on equal this block, and this is on, and then here we would just return cuboid on, and this one's cuboid off. True and false. I think that's a little bit better. Did I touch my glasses again? I did. I have another fingerprint on it. The on-off issue. The problem is that there are like two if-lets that, so there are two different cuboids, and I need them to converge. So I decided to have them converge through a tuple that we construct two different ways. Right? I could call this 1, and I could call that one 2. They don't have to be the same name. Just to illustrate, right? In fact, I probably should call them different names to illustrate that even more deeply. If we can strip a prefix on, that means this is an on cuboid. If we can find the prefix off, it's an off cuboid. So we take the on-off nature of it and put it out to a Boolean so that we can pass it to the parse here. I like this. I like that better. Okay, so then parse range looks good. Intersections looks good. Oh, wait, hold on. This can be changed to then. Intersection empty, then intersection. Look at that. One-liner. Run those tests. Make sure I didn't break anything. Oh, I broke something. Okay, we broke something, so I gotta back up. Let's back this one up first. Oh, it's backwards. That's what it is. It's not empty then. Run those tests again. Okay. Yeah, that's almost English. Not intersection empty, then intersection. Who am I fooling? That looks bad anyway you think about it. Anyway, it's one line though. It's cool. Let's move on. That's my iteration. I guess we'll just... Actually, did I even need this? I don't think I actually need that anymore. We're not iterating cuboids. Okay, so we can totally clean this up because I don't need X, Y, or Z. I don't need to compute X, Y, Z. I don't even think I need empty anymore. Don't need... Yeah, I can cut out a lot of this code. Do I need empty? I just used it, didn't I? It was this here. Do I keep it just for that? No, I can make this a method. Function empty self bool. And then put in front of these self. Get rid of empty here. Get rid of empty. This just becomes... And then I can actually reverse that logic. So let's call it, Full? Parse is always going. No, parse could be empty because we have a limit. But I don't need that anymore. Yeah, I could reverse this, right? What to call it? I know what I can do. I can make intersection actually return an option. That would be even cleaner. Yeah, because it's only used there. So we'll just make it return an optional self. And we'll say, yeah, all of this stuff here without the self. If any of these are true, let's turn it around. Not, and not, and not, then self. Got 12 desks all for yourself? They're all working from home today? That sucks. You drove in just to hang out with your coworkers and none of them are there? Can you put that in a match? Which match? I already lost the match that you were asking for. I'm sorry. Yeah, so then this just becomes cuboid intersection. This is super clean. There. Super clean. I don't need the empty function. You got more coworkers but from different apartments. So like beyond the 12 desks, so there's like a zone of 12 desks around you, and everyone is like on the edge of that zone staring and saying, why is Enduran there by himself? Prefer to work from the office compared to home? I do too, but problem is all my coworkers are like very far away. So I would have to fly to work with them in the same office. So, yep. Apartments or departments? Exactly. Is it the same in other languages? Or are apartments, departments completely different words? I think in French they're the same. They're similar words, right? Okay, looking for opportunities of cleanup here. I think we'll keep the on flag because we know when we do an intersection that we're flipping it. Parse just needs to be given it, and parse also incorporates a range, so maybe I'll rename this parse and limit, parse and clip. Yeah, because that's what we're actually doing. We're clipping. We're clipping into the limit. That's what we're doing. So parse range ought to be called parse and clip range. Apartment is like a house in a flat. Yes. The only French word you know is déjà vu. Was appartement and département. Is that right? Maybe I'm combining my English and my French when I do that. Département. Appartement. Okay, this all looks good. This can just be sum. Yeah, this is easier said with map cuboid volume sum. It's a string. It didn't like that because the signature is different. How is it different? Oh, iter. There we go. And do we need this? I think sum always needs that, right? Sum is one of those weird ones because it needs me to tell it the type, even though it should be obvious. From this, it returns an eye size, right? So you'd think adding up eye sizes would be fairly straightforward. No, it says type annotations needed. And I'm not sure why. In Spanish, they can be used interchangeably when referring to a flat. Je ne parle pas français. You have too many I's in français. And there's a little caret, what do you call it? Accent aigu? No. Whatever the one is under the C. Accent aigu is a different accent. I can't remember the accent for the C. All right. I haven't run the test in a while. Okay, still passing. Great. So if I had just known what to do from the start, this would have gone so fast because I didn't really have to write a whole lot in the end, right? If any region is empty. No, if all regions are not empty, then we have a cuboid, otherwise we don't. Parse and clip. I could combine these. There's no reason to keep these separate. And then these don't, that stays mutable, right? Yeah. So I can combine those. Can I turn that into something? No, I don't think so. I can say volume times self on 1 or -1. Nah, that's okay. Splitting hairs at that point. This is kind of cool. I liked how I did that. I mean, it's almost readable. Benchmark it and go to bed, I think. Cargo, bench, 22.1. I feel good that I was on the right track towards this person's solution. I feel bad that I didn't get this last part. I struggled trying to realize this last part, that for offlines, you just do the same calculation you do for onlines. You just don't add them at the end. You leave them canceled. 62 milliseconds for part 1. It seems rather slow. This is probably going to be a couple hundred milliseconds. No, it's also 6. So not that much slower. The number of the lines, the number of lines are the same. Yeah, so either way, it's the same speed now, because the only difference between the two is that limit clipping. Okay. Why not move the strip prefix into parse, clip range, and split once? Let's look. Because the argument's different. Oh, but I see what you mean. Like, we could just pass that argument separately. That's a good idea. So then parse and clip region would do... Could we do something with the iterator? Or are we going to still have that? I mean, we end up like highly specializing this function. That's what I'm worried about. This one works on any string and any limit. I could even make it generic over this eye size, right? And make this one generic. You know, I might as well. There, it's generic. Oh, can't do that? Why not? Oh, we have to say T from string. That has to be imported. Wait, what? Why does it need to inherit the debug trait? Okay, never mind. This is too much work. What's the original problem here? Parse? Yeah? When I did that, why did it not have a problem with that? Because I size... Oh, because... Okay, so then I guess I can do it with from string plus debug, right? And I have to... Sometimes I have to do this manually and I don't like it. Import that. Still no... It has to do with the error, I guess. Oh, because it's not T that is debugged. It's the T is from string is error. Oh, that's gross. I mean, we could do it this way. It's just gonna look ugly. Where T is from string and T as from string. How does that work again? It was in there. Oh, okay. T as from string error implements debug. Right, and then T has to implement add. And add's a standard op. Come on. Really? That's horrible. What was it again? All these trait bounds that we have to make sure. T as add output has to be a from string. T as add output has to be a from string. And then its error has to be debug. Oh, God. This is like not worth it. You know? This is not worth it. T as add as from string. Error is a debug. Oh, can you not even do that? What do they say? It needed to be? Oh, output. Still, this is a problem? Expected... Oh, dang it. One only works with iSize. It doesn't work with any T. You know, it's not worth it. It does look disgusting. Hey there, Gnarf. S split once dot dot unwrap. Split once equal 1 split once dot dot was what you meant. You just split by dot. Might move this. So you do not need it for each case. Oh, and then I misunderstood what you meant. So you meant, you're talking about this? Oh, you were thinking parsing it inside out, and I was thinking about parsing it outside in. I see what you mean, but I do need to remember if it's on or off. Okay, yeah, so making this generic is a problematic for a lot of reasons, not least of which is that I add 1 to the end, so it's only really going to work for types that are let's keep undoing. It only works for types that you can add 1 to. So I'm just gonna keep it non-generic. This can be generic though. There's no reason that can't be generic, right? Oh shoot. We get into trouble with this. Is that all? It just needs to implement ORD. Oh, and then yeah, we have this, so maybe default. And we'll say like T default to T default. Nope, we still have problems here because it needs to be also copy. Okay, that isn't so bad, but maybe it's not worth it because it uglifies that. Let's just leave it the way it was before. If there was an easy opportunity to make some of this generic, I would, but it's not really that easy. I think I'm just splitting hairs at this point. I could move the strip prefix inside, and like you're saying, I could parse it outside or inside out, and it would just look different, I think. You're saying I could do the strip prefix outside, but you can do that inside with the split once equal, but and just ignore the left-hand side, you're saying? Okay, I see that. But this will catch if it doesn't say x equal. That's the thing. Your solution would just ignore what was on the left side of the equal unless we added another expect or assert or something. I think I'm gonna just keep it the way it is. Just clean it up. All done. Yeah. So I got stuck and I had to look at Reddit, and my solution went the same way as this person's. Only I figured this much of it out. And then I couldn't figure this part out, basically. I couldn't think of this last part, and so I couldn't come up with it on my own. So I went to Reddit and I saw this. When I saw this solution, I'm like, oh yeah, it's exactly what I was thinking. And then we got to here, I'm like, oh, that's how you solve that part of it. I didn't look at the code. I just, once I got the aha moment from someone else, I went back and fixed it. One thing I don't like about split once is it gives the tuple of borrowed value instead of own value. Well, you can just use copy types if you don't like that. The split, all the split and strip, the idea is not to do any copies, right? So we're always borrowing at every point. Why does this say char? Oh, because the fundamental type is characters. You did console.js, you have been golfing while watching other people? Nice. Both have the same problem, just unwrap even when it's not found. True, but I could turn this into something nicer, saying we expected this prefix. Actually, then it would be better to just put that into as a parameter to this function, have that function do it, right? Yeah, I don't know. It's splitting hairs, I think, maybe. I think I need to go to bed. Is there? We can look and see if anyone else is still working on this problem. We can go watch them. Let's see. Following. I should be back tomorrow to do day 23. It's too bad Musin's not doing Advent Code right now. I don't see anyone else doing Advent Code, so I gotta branch out and look at the browse creative software and game development. It's kind of nice that we can browse directly there now. There's me. Is there anyone else doing advent of code? Is it too late for advent of code? I guess I can do a search. Not in tags, but up here, advent of code. It's just me? No one is doing advent of code but me. How about AOC? I find that hard to believe that no one else is doing advent of code. It's funny. Search for AOC, you find the senator. But no streams with that in the title. That's just weird. No one else is doing it right now. Maybe do AOC next year and try to brute force it every time. You mostly do another method. See, Rasubaka, you would have had a hard time with this one, and I think it was like day 17 or something, because going back to the description of the problem, you can do part 1 brute force, but when they say that you'll need to have this many cubes, if your brute force solution was to have an object in memory for every cube, already you know that you're not going to be able to brute force it. What was the question? Flex Lolo. Hold on, I missed some chat. What am I missing? Wait, how come they're not showing up on my list? Way at the bottom? Then what was the title of their stream? How come it didn't show up in my search? Yeah, that's what I searched for. How come we didn't find it? Okay, we'll raid them. That sounds cool to me. Yeah, I'm mad that I couldn't find it myself. I did the search and everything. Okay, here we go. Okay, channel is intended for mature audiences. So be warned. I'll be back tomorrow to do day 23. Have a good day. Good night, everybody. Bye. Thanks for watching. Bye. Sorry for being muted for about 5 minutes in the middle. Bye.